thank you for that kind words. Yeah, it is actually my first time ever to make this presentation on standards with a question mark behind it, and then no standards in the same kind of sentence. I've been working on standards for the best part of 35 years, and I love standards. So, yeah. And then I've added one more kind of a line here. It's a question of perspectives, and I will try to come back to that on my last slide. But anyway, I will go through these three items, a little bit on the automotive industry, and then on two projects that kind of highlights the difficulties with standards, even when they are in place, and then what do you do when there is no standards, and then a little bit on can we live with that chaos. And the automotive industry lives with that chaos. So I guess a lot of you have seen films like this. Automated cars pulling out of a parking lot in Phoenix, observing that there is a roadblock ahead immediately, and swing or turn back into the parking lot. And the car knows that going through that parking lot there is a building. If I go around that building, I will come back onto the streets again, and I can continue my journey to my destination. So these cars knows exactly what they are doing. They have an HD map, high definition map, of that confined area of the downtown of Phoenix, which this is in. And this is a 2-year-old film, and these cars are getting better every year. So these cars are almost self-contained. They will be able to drive and negotiate and help themselves through the traffic, and they really don't want much information from the outside, from the external side. And one of the reasons is that they don't trust data from other sources than from themselves or their own car makers. So the cars can map the environment. They can observe traffic lights, traffic signs, road markings, so they can navigate, they can negotiate traffic, they can maneuver in very tight corners, and they can communicate with each other and the back systems of their car makers and what we call the OEMs. They don't want to have data from outside, but there is a little blue sector here, and that is the public side. They want to give the cars at least a navigational road network, so you can get from A to B. They want to give them the conditions of the road, if it's slippery, if it rains, if it's potholes or stuff like that. And also the regulation. All the traffic rules needs to come from somewhere. And also in the likelihood of accidents, roadworks, congestions, that might come from the road management system at the public side. So there is some data that they want to kind of get from the public side. But most of the time, they will drive without any help from the outside. And that is the thing with the automotive industry. They don't actually trust anybody else but themselves. Even though in the EU at least, and I suspect also in other countries, there are a lot of rules and regulation. This is two parts of the ITS directive in Europe, RTTI and SRTI. That's real-time traffic information and safety-related traffic information. It is mandatory for the public authorities to push that onto the cars, so they know at least the most critical rules on how to behave on the road. They give them the instructions how to use the road network. So even EU has put up. Shit, I'm on the wrong page here. That was not the meaning. Okay, so this is the RTTI and the SRTI that I was talking about. Sorry for that. These are two kind of directives that are in effect in Europe, pushing crucial data and crucial real-time data and regulations onto the cars in that blue sector on the previous slide. And that is accepted by the car industry, that this comes from the public sector, because they need at least to have at one point in their kind of download of the data, the correct information, and then they can correlate the information on board the cars with what they get from the public sector, which is the correct one.
So this is the dilemma that we are working with in the road administrations. The car don't actually want to work with us, but we push data onto them anyway. I have to check now. So this is a little bit of the state of the art, and I'm going to give you 2 projects here. The first one, and this is a simplification. And what I'm going to say here is a simplification and also an exaggeration. So don't quote me too much on what I'm going to say now. So we have the Public Roads Administration at the left side. Then you have the service provider in the middle, and then you have the users on the far right here. And this is only one out of maybe 100 use cases. You want to ship traffic regulation through this abundance of service providers that we have here onto the cars on the road. So if the rule makers on the road administration side kind of very neatly locate a traffic rule like a stop line or a speed limit sign to start on a particular meter on a stretch of road, they have done their job. I don't know if this works anymore, but anyway. Once they kind of store it internally in their own database, in the national road database, this is an example from Norway, they have a different standard in that road database than the guys who actually made the traffic rules. So even there, even storing the data will kind of shift the location a little bit because they have a different method of locate, maybe a different standard, maybe a different road data model. And when they publish that data through the service providers, where you have CITS, which is the king of standards, not in use yet in Europe, at least not widespread. And then you have OpenStreetMap, you have Overture Map, you have Google Maps, you have TomTom here, you have TISA, Datex, and TNITS. All these families of standards all have their own way of locate and define the same objects and traffic rules that you have on the left side with the Public Roads Administration. And then they ship it all the way to the car makers using NDS, Navigational Data Standard, and into the cars on the road. And the cars observe that this stop line has shifted maybe 50 meters from what it says in the data from the road administration, because they can observe it using the camera, LiDAR, laser, or whatever kind of technology they have on board. This is a problem for us. And then even after that, we demand, through that same legislation that I showed you before, that this data, the discrepancy of the data, also is reported back to the public authorities using the feedback loop at the bottom here in the white field or the white area, and do a correction demand to the road administration so that we can align what the cars observe on the road and the speed limits or the whatever object is in question can be corrected in the database or at the rule makers level. Going back there are no standards. Absolutely, there's a suggestion that you can use Datex, but most of all, you get proprietary data coming back. One sort from Volvo, one from Mercedes, one from Toyota. You have to learn to live with a lot of different streams of data coming back. This means that you have, even if you have thoroughly standards floating to the right, you have no standards floating back again on the bottom here. And even if you have a lot of standards, it doesn't help you. The data is deteriorating as you go to the right because of different road data models, different feature catalogs and stuff like that. And then we have another project. It's actually harvesting data from the cars on the roads. If it rains, if the window wipers is on, or if there's a slippery road, the wheels are spinning a little bit, or the ABS brakes are on or something like that, then the data can be shipped back to the service kind of production and on the lower left on the right side, on the left side of the screen, to make new kind of services for the cars on the road so they can do deviation or avoid slippery streets or stuff like that. But they also have to learn to live with the feedback loop that doesn't actually is standardized. So they have, in this case, in number 2,
they work with Volvo in one project, they work with Mercedes in one, and Volkswagen in one, and they have different setups for each of those. Even within the Volkswagen, you have to learn to live with different systems, even within the same concern or firm. So this is the way we live with chaos. And to highlight this a little bit, this is a small piece of map south of the Oslofjord and in Norway. And everywhere you see a red or a blue or a green dot, there are some errors. That means that the data has shifted a little bit due to lack of location method. And this is between OpenStreetMap and the road database in our organization. And that is because some of these standards, they are based on a simple topology of a node and edge, or a node or link. And everything you see of traffic signs and lane markings, lamp posts, guardrails, or whatever, is located according to the green line. And of course, if you have a situation where you also have a kind of a node link structure, a topology that is true for every lane, you can make a much more detailed and accurate location of all your equipment. And this is the case. In the road data bank, we have the red one. OpenStreetMap might have only the green one. This shifts everything around. Another example from Knut Jetlund's studies or research is overture maps compared to the road database in Norway. And you see on the first screen here, you have these blue lines. That is where OpenStreetMap thinks it's 110 kilometers per hour, but the road database which it has the truth knows it's only 80 kilometers per road. That is because they lack that segment of the road in the in the overture maps. And overture maps gets its data from OpenStreetMap. And OpenStreetMap might get it from the road data bank in Norway, but also via other sources, maybe from the cars on the roads. So another example here, also from overture map. You see that the yellow or orange lines here is the road data bank in Norway. You have a road level and you have a lane level, but overture map only have the road level. And in the same roundabout here, you have the local or the national road data bank has both levels, but in this case, overture map has only the level, the lane level, meaning it's impossible to make correct location for very vital information like stop lines or other kind of markings, or even the start and stop of a speed limit, which is crucial to traffic safety and traffic management. So this is the kind of the world that we live in when you are in the road administration these days. You have to cope with what we call chaos. So going back to this slide, I've called it the trouble. There are two boxes here, and actually it's like two paradoxes. The one is that you have to live with, in the black or blue box here, you have to live with the fact that you have an abundance of standards. They're all made to an ecosystem that is very important for that particular kind of business that they're in. Like TomTom here is completely different from CITS or TNITS. They all have a purpose, but they use different ways of locate things. They have a different road data model in them. That makes it a problem. That's why we are doing the Joint Working Group 11. But you see the sheer number of actors here is overwhelming to kind of correct. So we have to live with a situation where the standards are destroying or deteriorating the data due to different definitions sets and location sets. And then on the other hand, if we really want to take advantage of the enormous amount of data that is created in every car on the road at any given time, to kind of provide
enhance traffic safety, enhance traffic management, flow of data, reduce congestion, emissions, and everything. You have to work with data coming from the cars on the road and try to make correction to your data where the road at a bank and the public roads administration has it wrong, so they can correct it. And you also have to work with the same feed of data to make new services that can further improve the comfort and the safety on the roads for the cars. So you have to live with different streams of proprietary data coming out of the different actors in here, and we do. I think this is the state of the art around the world. We are used to work with chaos, and we manage, but it shouldn't be like this. It should be streamlined, and you should have the same road data model, the same definition of a speed limit, the same definition of a stop line, of course. So these boxes is our kind of the work that we are doing, the work where we are at the moment, both in the standardization world, but also in the road administration. And the OEMs take whatever we get to them, but they don't trust it until they have checked it themselves. So there is actually maybe one exception to that. And in Europe, you have a law that will force every car to have an ISA system, that is intelligent speed adaptation. That means that the car should warn you if you overspeed, and that will be mandatory from 2026, meaning that we have to do some fixes to this in 2026. The red box is maybe a challenge to the community of standard experts. Is it possible to make some kind of standard for a non-standard kind of use case? I don't know, but eventually something will happen here, but that's like an open question still. And then my last slide, to be sure, is the perspectives, coming back to that. And in my entire life, I've been living in that area of my professional career. So I've been looking at the world from the public sector side, slightly into the blue box there. And I've looked at the world from that perspective. And I assume I know what the cars and the vehicles and the car makers need from data. I actually don't know, but I assume. And if you go further to the left, if you're a rule maker, you will make traffic rules with like 100 parameters in it, while the vehicle maybe only maintain 80 kilometers per hour, stop, pull over, start, like maybe 3 to 10 parameters. We never asked. We had just assumed. And I'm quite sure that the guys who make the electronics in the car never bothered to ask the Public Roads Administration, what data can you provide that I can use? They make their standards, they make their kind of systems in peace. They don't even care about the other perspectives. And this is exactly what is the problem. We make systems and standards standing in our own corner, making assumption of what the other guys need from our data and from our systems. So I think this is why we need Joint Working Group 11, Joint Working Group 14. Maybe we also, like Chris suggested yesterday, joint technical committees to actually pull the perspectives together at least sometimes a year. So this concludes my presentation. Thank you.
Thanks very much, Trond. I did like your slides. They really set out the issues really, really clearly. And I think the one thing that stopped me when I was watching the slides was that at the heart of that is location, really, isn't it? It's you've got car professionals on one side that don't fully understand the nuances of location. That's what we do. Anybody got a question for Trond? Yeah, hold on a second. Paul, yeah.
Is it work? Yeah. Thank you, Trond. Very interesting. And I will talk to you, I think, this afternoon about this ITS directive and everything. And well, chaos is interesting, of course, but chaos exists in human life, and you have to deal with some kind of chaos. And standards kind of assume that chaos does not exist, you know, but that's what we have to deal with. And maybe AI can do something in I did Mercedes, all the cars, Volvo, and every car maker provide lots of information that we can use, but that's commercial information. You can buy that information, and I know that we are doing that also from the public administrative side. So they have a business case, and the business case is helped when they have satisfied customers, and the public administration is a big and large customer of that industry. Can't you influence them through that way, you know, the economics of dealing with the industry as a big and large customer?
Yeah, that's a very good observation. We also buy data from these car makers, the OEMs, but the problem is that we cannot use it. We cannot blend the data because it's so different than what comes out of the different car makers. So we buy them maybe from TomTom here or somebody that kind of assemble the data and make them more readable for us. But still, yes, of course, that is a way to do it. But we should have a kind of at least a possibility to have a clear stream of data coming to us that we can actually use, especially when it comes to traffic safety. But I do agree. We buy, and that might be the solution, the end solution as well, that we just keep buying data.
Okay, thank you. I think Chris had a question. Yeah. Is there a question online? No. Chris?
Okay, that's a fine. So one of the challenges here is as commercial actor to get data and information from many all over the world for the solutions you want to make. So we really need the international standards to make this feasible. But there is a lot of work now ongoing on creating data spaces. The European Union investing really heavy in this, and there is also one project. Deploy EMDS, European Mobility Data Spaces. So I'm wondering, are you looking into that, and do you think that could be a part in also addressing and helping us with these problems?
Yeah, I think the data spaces coming out of the EU, like the mobility data space, is a way to try to help us do this. And we have been diving into what we call MDS, without actually understanding exactly how that works still or yet. But I think that might be one way of looking at this. So yeah, it's a very good observation. I could have included it in my presentation, but I forgot. Thank you.
Okay, we do have to move on. So thank you very much, Trond. Thank you.